So on Monday, you already learned about data pre-processing. You learn about the EDA. You still remember EDA? Exploratory data analysis. And then you also learn about data cleaning and how to transform the data when there is missing value. So today I'm going to teach you two things. The first is regression and classification. So it is a part of the supervised learning. What is supervised learning? We will learn today. The first part is about regression. There is a concept, we call it supervised learning, or maybe in Korean, they call it 지도학습. We call this is supervised 지도. It means there is a supervision. Every data, the training data, or we call it observations, or we call it measurements, are accompanied by labels. So if you have data with labels, then it indicates the class of the observations. So for example, I have a picture. We have a lot of pictures in the world. But when you put a label, okay, this is a dog, then it means I would like to do the supervised learning because I have a picture and I know that this picture is a dog picture. I have another picture. So this is another picture and I know that the label is cat. So we call this label is the label for supervision. And for this data, usually we will do tasks like classification, regression. So new data is classified based on the model developed by the training set. So today we are going to learn what this supervised learning, and there are two tasks, classification and regression. So regression and classification, what is the difference? When we do regression, so we want to do with the target attribute, we call it the target attribute, and the target attribute will be numerical. So you know, in our first or the second week lecture, we know there are two kinds of data. You still remember? Yes. Yeah. Numerical and categorical. Okay, good. Thank you. So we have two types of data, and we also classify the supervised learning into two types of methods. If it is regression, then the target attribute is numerical. If the target attribute is categorical, then we call it classification. Okay. How about the attribute? So mostly, I can say the attributes are numerical. Most, it means 대부분 attribution numerical. But for the classification, most of the attributes are categorical. So we will check later with examples. Examples for the regression, we can do like price prediction. We can do demand prediction. We can do stock prediction. For the classification, there are some examples like credit approval. So yes or no. Target marketing, yes or no. Medical diagnosis, positive or negative. defect detection, defect or not defect, spam detection, whether the email is a spam or not spam. So based on this category, now let's look at the first example. So this is an example from Orange. We will do Orange today. So this is, oh, I think I need to write this one. This data set, we call it advertisement data set. So I can open the Orange. And then you can go to the data set. Okay, there is a data set here. And in data set, you can search for the data. So we have advertising data set. You can find advertising data set. And you can also see the description. Here is the description. So the description shows that this is the advertising data that contains on advertising budget. This is Panggo Yasan. There are three kinds of budget for the advertising: TV, radio, and newspaper. And we want to see the sales. And it measures in thousands of dollars. Means the unit will be in thousands of dollars. Now, you can see all the details in this data description. So when I give you later exam, I will also do the same. So I will give you data, and then I will give you the information, what are the column. I will give you what are the description, and then you need to analyze. So this is the data. So you can double click. When you do the double click, you can see that the data now has been downloaded in Orange. You can see the green color. Okay, so if it is green, then it means you can read the data. Now I can try to read the data. It takes some time. Okay, I can open the data. And you can see here, we have 200 instances. It means we have 200 rows. And then we have 3 features. Why 3 features? We have 1, 2, 3. We have 3 columns. And the cells, we call it as the target. We call it as target. These 3 features, and this is the attribute 1. This is about TV, television. This is attribute 2, which is about radio. This is about newspaper. So I want to see, this is company 1. The company 1 spent 230.1. So in the description, it shows that the unit is in $1,000. And what does it mean? It means we have company 1 they spend 230 US dollar for TV advertising. This company one spent 37,800 US dollar for radio advertising, and this company spent 69,200,000 US dollar for advertising. And as a result, this company got the sales 22,100 units. I guess, yeah, this is unit for the sales. Now, let's see the data number 2. What does it mean? Based on this information, we can also give the description. Okay. So maybe in the exam, I will ask you one question. 이런 질문도 있어요. 이로가 무슨 의미? Then you need to explain. So in this case, the company two spend the TV as much as 44,500 USD, and radio as much as 39,300 USD, and then the newspaper, they spend what 45,100 USD, and they get the sales as much as 10,400 units. Okay, and so on. Now we can see that this data is numerical. This data numerical. Now we want to decide. Let's say I have a company and I want to spend some money for the advertising. I want to spend some money for TV, I want to spend some money for radio, and I want to spend some money for newspaper. Then can you predict the sales? So we say this is the target, or this is the decision variable. So I want to decide what would be the sales if I spend the money on this aspect. So you can see here the column we have TV, so it is the spending on TV advertisement. Radio, it is the spending on the radio advertisement, and newspaper, it is the spending on newspaper advertisement. And the sales means the total sales that you get when you spend on this media. So this is the target, and the other is the attribute with numerical. So let's just use the numerical for this moment. Now we will make a simple flow. Okay. We have the data set. So at the first time, you need to do the data selection. After you have the data selection, I skipped. There is another part actually. You learned last Monday, we have the data pre-processing. We have data pre-processing. So actually, before we do the model generation, we need to do the data pre-processing. But this data is good. This data has no missing value. This data has no noise. So I will just continue with the model generation, and then we will learn the model interpretation, and then how to check the prediction. So we have the data set. If you want to see the statistics, you know how to see the statistic. We can open the feature statistics. In the feature statistics, you can see the mean, the mode, the median, the dispersion, the minimum, the maximum value, and the missing value. So there are no missing value. And the mean of the TV advertisement is 147. The mean for radio is 23. The mean for newspaper is 30. So the sales, the mean is about 40. Now, I want to do the modeling. We have the model generation. And then I will give you the explanation what is model interpretation and the accuracy of prediction. So the model generation. So we have one model, we call it linear regression. In the linear regression, this is for the regression purpose. So what is regression? Regression, it is the supervised learning when the target is numerical. Okay. So regression, we call it regression, is the supervised learning when the target is numerical. Now, there are some, we call it options. There are parameters. So it is the basic fit intercept, unchecking it, fix it to 0. So if you want to have intercept, you can just check this one. If you do not want to have intercept, then uncheck. Uncheck means I can remove this one from the analysis. Regularization. So there are many options actually for the linear regression, but let's just learn the basic option or the default option, no regularization. In the linear regression, we have attribute TV, attribute radio, and attribute newspaper. So let's say if I put into the mathematics, so this is the X1, X2, X3. And then the sales. The sales mean the decision attribute. So we say this is Y. Then in the linear model, we can make the model something like this one. Y, or this is the decision variable, is equal to alpha. So alpha will be the intercept plus beta. Beta is the weight for each attribute. So beta 1 is the weight for the TV multiplied by the X1. Beta 2 is the weight for the radio spending multiplied by the X2. Beta 3 is the newspaper spending. This is the weight for the newspaper spending, and this is the newspaper spending. Plus error. Usually there are maybe some errors, but for this class I will not discuss the error. Maybe you will do this kind of more studies in other classes like statistics, probabilistics. So we can do the modeling with the linear regression, and we will get like this one. So we have the intercept, we have TV, we have radio, we have newspaper. So the intercept means the alpha. The TV, we have the coefficient, this is the beta 1. The radio is the coefficient is beta 2. And the newspaper, we can say this is the beta 3. Now, we can see the value. For the intercept, which is the alpha, is 1.85. For the beta 1 is 0.06 something something. For the radio is beta 2, 0.23 something something. Newspaper is beta 3 minus 0.06. Then we can put into the notation something like this. Alpha. The alpha is here. The TV is here. The radio is here. And the newspaper is here. Now, what does it mean by this model? So we can do the interpretation. For the TV, an increase of 1 unit. So here, let's say if x1 equals to 1, what happened? It means if I have a budget 1,000 US dollar for the TV, then this will be 0.06 multiplied by 1. So the formula will be, let's say, x equals to 1, x1 equals to 1, x2 equals to 0, x3 equal to 0. Then this is 1.85 plus 0.06 plus 0 plus 0. Any number multiplied by 0 will be 0. Any number multiplied by 0 will be 0. So I can say that if I spend 1,000 US dollar on TV, then the sales will be 1.85 plus 0.06, or we can say 1.91, or this is 1,910 units. Okay. Now, let's say I have x1 equals to 1, x2 equals to 1, and x3 equals to 0. Then, what happens? This will be 1.85 plus 0.06 plus 0.23 plus 0. Okay. Now, let's say I have also x3 equals to 1. Then it means there will be a number here, 0.06, but it will be minus. Okay. It means if I spend a budget on TV, the increment of 1 unit will increase 0.06 point of sales. Yeah, if it is in US dollar, then I can say this is 60 US dollar. So when you put your money on the TV, 1 unit or 1,000 US dollar, there is an increment of sales 60 US dollar or 0.06 point of sales. If you increase the radio of 1 unit or 1,000 US dollar, it will increase 0.23 point of sales. But if you put more money on the newspaper, what happened? Because we have minus, then it will decrease the point of sales. Okay. So let's try. Okay. I'm using this result from the first 10 data. Okay. The first 10 data in the orange. So let's see. I use the first 10 data. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can block this data. After you block this data, then you can do linear regression. Okay, so in the linear regression, I can just put the fit intercept and then no regularization. And then I can put the data table. So in the data table, you can see this model. So this is the model that I just show you in the PowerPoint. Intercept, TV, radio, and newspaper. Now, after I have this model, I want to check whether this model is good or bad. I can do with the test and score. So when you do with the test and score, nothing. It means I need to provide the test and score with some data. So I need to give the data from this data table into this test and score. And now you can see the score. Okay. So this is the score. Now we will discuss this. What is MSE? What is RMSE? What is MAE? What is MAPE? And what is R square? Okay, we have the test score. And today I'm going to teach you two things, which is about the cross validation and the random sampling. When you do with the cross validation, this is the result. When you do with the random sampling, this is the result. You can see there are some slight difference on the numbers. So what happened with this one? Let's see one by one. First, when we want to evaluate the model, we can do the train and test split. Train and test split. So the data set is split into two groups. We call it the training data and the testing data. And the training data should be different from the test data. Usually the training set is larger than the testing set. You know why? Accept data to mana itu? Because if we have a lot of data, then it will produce a good model. Okay. So there will be some ratio. Ratio means if I have 10 rows of data, so how many data for the training set and how many data for the testing set? Let's say if I put 90 and 10, it means 90 of the data or 90% of the data will be for the training set and 10% of the data will be for the testing set. Or we can also put 80-20. 80% of the data will be for the training set, 20% of the data will be the testing set. Or we can also do with 70-30 or 60-40 and so on. But is it possible to do with 40-60? 40% for training and 60% for testing. Is it okay? Actually, it's okay, but it's strange. It's something. So we need to have more data on the training in order to make a good model. That's why usually the ratio will be something like this one: 90-10, 80-20, 70-30, 60-40. So the ratio of the training data will be higher than the testing. The other kind of evaluation methodology, we call it the cross-validation. So the cross-validation means we want to ensure the reliability, silasol. So the evaluation steps can be repeated several times to determine average results. So we have what we call as n-fold cross-validation. This n-fold cross-validation means if I set the n equals to 5, then I will split the data into 5 groups. So I have 10 rows, so I will split into 5 groups. The first group, second group, third group, fourth group, and fifth group. And then I will do something like this one. The first group will be the testing, and the number 2, 3, 4, 5 will be the training. And then this is the first iteration. I will do the second iteration. The second group will be the testing, and then the remaining will be the training. This is the third iteration. The first and second, fourth and fifth will be the training, and the number 3 will be the testing, and so on. So we will do the repetition until 5 times. This is what we call as n equals to 5. What is n equals to 10? It means we will split this data into 10 groups. So we will do the first group will be the testing, and the remaining will be the training. So there will be 10 times repetition. And we will check this performance, and then each of them will have performance, and the performance, and then we will check the average. So whenever we do with the regression, there will be some measurements, we call it error rate. So this error rate, there are 4 error rates that we can learn in orange. The first error rate, we call it mean absolute error, or MAE. So it computes the deviation between predicted values, which is P, and the actual values, which is R. And then we do the absolute value and we do the summation. For the mean square error, or we call it MSE, it is similar to MAE, but places more emphasis on the larger deviation. The RMSE, or root mean square error, is the root of MSE. So this is the formula. We have the P, which is the predicted values, and R is the actual values. And then we do the square. Okay. At the end, we can also do the RMSE, or root mean square error. So this result, we will do the root. So that's the meaning by root mean square error. We have the mean absolute percentage error, or MAPE. So it is the ratio of the deviation between the predicted and the actual values. So the actual values minus by the prediction divided by the real value, or the actual value. And then we do the absolute and we divide with the number of data. So let's see with example. there's another things about R square. Okay? So the R square, we have the total sum of square or SST. SST is obtained from this formula. It is the summation of the square difference between actual values and the mean of actual values. So R is actual value. R bar is the mean or the average. And then we do the square. We have sum of square residual or SSR. It is the summation of the square difference between the actual values and the predicted values. So we have P, which is the predicted values, and R, this is the actual values. And we just do the square and do the summation. So the R square formula will be R square will be 1 minus SSR divided by SST. The values between 0 and 1 indicate the proportion of variation explained by the model. So if we look at the example later, if the R square is 0.5, it means that 75% of the variation is explained by the independent variable. Let's see example. How can we measure the error rates? So you already know, we have the TV, we have the radio, we have the newspaper, and this is the sales. So let's say we have the model that you saw before from the regression. We can put this number, we can put this number, we can put this number, and the result is, so this is the actual value, and this is the predicted value. So how can we get the predicted value? This is from the model. This is from the model that you get y equals to alpha plus beta 1 multiplied by x1 plus beta 2 multiplied by x2 plus beta 3 multiplied by x3. And here we just put this number. This is the x1, this is x2, this is x3, and then this is the prediction. Now we want to check the model. If the model is good, means the error should be very low. So you can see here, what is the error? The error is the actual minus by the predicted value. 22.1 minus 20.8. So the error is minus 1.3. Okay, so you can get this one for all the errors. So this is the error between the sales and the prediction. So what is the MAE? MAE is just the summation of this one. So you can check. The MAE based on the formula, what is it? We need to do the absolute. So if it is negative, then it should be turned to positive. Then we will do the and you will check. This is 1.3 plus 0.6 plus 0.1 plus 1.2 plus 0.9 plus 1.8 plus 0.1 plus 0.1 plus 2 plus 3.1. Then we have 11.2. We have 10 data, and it means we will divide with 10. So the MAE equals to 1.12. What about the MSE? The MSE, mean square error, it means for this deviation, we will do the square. So for the deviation, we will do the square. So I show you this one. This is the error, and then we do the square. Then you can check 1.69 plus 0.36 plus 0.01 plus 1.44 plus 0.81 plus 3.24 plus 0.01 plus 0.01 plus 4 plus 9.61. And we have 21.18. And we have 10 data. Then we will divide with 10. So the MSE is 2.11. The RMSE, what is RMSE? It is the square root for this one. The square root from this one is 1.451. What is the mapping? You can use the formula to calculate the mapping. And R square. What is the R square? So we have the R square is from the SSR. This one. R square is 1 minus SSR divided by SST. SST is the value, the actual value minus by the average of the actual values. And this is the error. We can do the summation. And then this is the sales minus the average sales. And then we do the cube or the square. So this is the total or the sum of SST. This is SSR. So we can calculate 1 minus 21.18 divided by 233.176. So the result is 0.09. And this is the result. Okay. Okay, let me stop here. Let's have a break. I will continue after the break.